Reading and writing to local files is a big part of working with server-side code, so we're going to look at how Node can work with local files in this screencast. To get the File System API, we can get the FS module. Now, there are really a lot of methods that you can use through the file system. You can create files, you can create directories, rename directories, change ownership or permissions. We're going to stick to reading and writing files, though, which are what you're going to be doing 90% of the time. So to read a file, it's as simple as doing fs.readFile, and then we pass the file path. In our case, let's make this files.js, which is this very same file that we're writing right now. And then we pass a function which will receive the content from this file. You might remember our lesson on asynchronous functions, and readFile is definitely one of these. So it receives an error and the data as two parameters to the readFile callback. I should mention also that there is an fs.readFile sync, which will take the file name like this, and it actually returns the file data. However, you usually want to use asynchronous functions, so that's what we're going to do here. And we'll just do something very simple here. We'll console.log our data, and it is a buffer, so we have to convert it to a string by doing data.toString. All right, so let's give this a try. I can do node files.js, and you can see that the files.js file was printed out to our console here because that's what we told it to do with that data. We can do a similar thing with the write_file function. First, we would pass the file name, so I'll just say text.txt, for example, and I can say this is the content. That's the second parameter. And then we have our callback function, which has the error if one occurs, and that's really the only parameter we're interested in. So let's say if there was an error, we'll go ahead and throw that error. Otherwise, let's do console.log, and let's console.log fs.readFile sync, and we'll read the text.txt file, and we'll just say .toString, because remember, a buffer will be returned. And this way you can actually see what was written to that file, as well as seeing the readFile sync method in action. And now let's run the file again, and you can see that this is the content was printed out. So we wrote that content to a file, and then we can read it back out. Before we wrap up, I want to show you that we can treat files as streams, like we learned about in the last screencast. So for example, let's start by creating a read stream. So I'll say our read stream equals fs.createReadStream, and then we pass it a file name. So we'll say files.js. So let's turn this file into a read stream, and then we can take this stream and we will pipe it to process.standardout. Right? So instead of printing out our file as we did up here, and we're doing the same thing, but in a different way. We create a stream that reads from this file, and then we will print out the result of that stream to standard out. Let's see if this works. There we go. You can see we have the content of our files.js file being piped to the console. But we can also create a file that is a writable stream. So let's create a write stream instead, and we'll say fs.createWriteStream, and this is going to be the fib.txt. And then let's get our Fibonacci readable stream, which we created before. So I will require fib, and then we can say fib, and we're going to pipe it to the write stream. Before we actually run this, let me open up fib again, and let's add our if statement here to stop it after a certain amount of time, so that this won't run infinitely. We'll say if b is less than 144, then we will carry on with pushing numbers in. Otherwise, we'll go ahead and do rs.push, and we'll push in null. There we go. All right, now let's run files.js again, and we won't have any output. But if I cat out fib.text, you can see that our numbers were printed out to our file. And so we were able to create a readable stream, and we were able to pipe that to a writable stream that happened to be a file on our disk. And so that shows you how the file system can actually interact with streams, as well as just reading and writing files using the method that we looked at earlier. Now, there's a lot more that you can do with the file system API. If you go to the documentation, you can see that we can rename files, we can change the ownership or the permissions on files, we can look at file statistics, we can create symlinks, we can make directories and read directories, and we can use fs.exists to see if a file exists, and there's a lot that you can do with files. Most of the time, though, you're just going to want to read and write files as we've done in this lesson, but do remember that there's a lot more to the file system API than just that.